Hello, students. We had a question on number 21 out of 14.2. And so let me zoom in just a little bit more here. Fixed point of a transformation is a point whose image is the point itself. So I want you to think back to the activity we did in class, where you were doing things with the mirror to find the image over a reflection, let's say. And you might have found a particular point was actually the same point it was when it started. And you can also open up GeoGebra, of course, if you want to kind of practice that. And let's see here. There we go. Calculators, geometry. Do I want to recover it? I don't think so. Is it wonderful? Yeah, that was from a student, not from me. Someone really enjoying the idea of extremely cool shapes. So let's see here. Let me go and clear all. And let's go to yeah, so if you just create a line and then pick some points wherever, and then what we're going to do is we're just going to reflect those points over the line. So if it says reflect object in line, and so if I click on an object and then a line, I can see the reflection of the object is point C prime. So I can see C became C prime. The question you're asking yourself is, did the starting point end up at the exact same point as the ending point? Now, if you choose the move option, you can kind of move this and say, no, 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 those are clearly different. What would it take for those to be the same? I'm not going to give it to you, but you can kind of see if I go this direction, they're further and further apart. If I go this direction, they're closer and closer together. Maybe there's a point in time when they are exactly the same. And you might say, oh, just put on the other side. That'll work. Well, if I put it on the other side, now the reflection's on the other side too. So you got to be kind of careful with that. But there might be a point somewhere where those two are exactly the same. And that's the idea of the question. What would it take for a point, just a point at random in the plane, to do these things to it? Like if I do a reflection to that point over a line, when will the point be its image? When will it actually be the exact same point? What will happen with a rotation? What happens if I rotate everything around a certain point? Which point or points will stay exactly where they started under this rotation? And you do it for a reflection rotation, for a translation, and then of course for a glide reflection. All right. So that's it. Now be careful, just so we're on the same page. It doesn't mean that it becomes another defined point. And let me clear everything to kind of show that's a little bit different question. So if I started with a segment, and that'll be kind of my point of that'll be kind of my rotation. And then I pick, I don't know, a polygon. Let's just say here's a polygon, right? And then I go down to translate by a vector, and I say, okay, take this thing and translate as A goes to B. You can see CED became C prime, E prime, D prime, right? So I'm not asking what can I do to make one of my points, like here, can you see how the point C, C became C prime, which is actually exactly the same as D. So if I move that label, this is D, it's also C prime. It's not asking what points move to become on top of another point. It's which point maps to itself. Okay. So what kind of a translation and what would that look like? Again, if I stretch this, then obviously it fails. So then I have to move those. But that's the idea. And again, you can move it to E prime if you want to, but this case right here is a great way of showing that sometimes I don't have to relabel my points because it already had a label. But that's different than what the question here is asking. It's saying which point, it's a point whose image, which is what, remember the after is the point itself. The point itself is the before. So when does the before equal the after? That's the goal. All right. All right. Hope that helps. Off you go.